And I would like to invite the first invited speaker, Professor Dr. Wlodek Kulesza, to make presentation Applying Science Future, Scientific Alliance of Academia and Industry, VTH Bioseco case study. So, stage is yours.
Okay, thank you very much. And now I have to deal with this technical issue that everything is working, because this is always a little bit scaring if I can share what I want and so on. So now I have to start my presentation, sharing screen. And this will be this one. And if something will be, oh, did I? So this will be here. Okay, does everything working correct?
Yes, yes.
Do you see everything? Because the most important is that we trust in electronics, but sometimes electronics put us in some, how to say, try if we know how to use it, you know, because electronics is perfect, but human error is mostly the biggest problem. So I hope that now everything is working. And so this is my first slide. And first of all, thank you very much for continuing this conference and to be honored by your invitation to be first invited speaker, which is quite challenging, because always someone who opened the conference should put, let's say, good quality. I hope that I will not disappoint you and everything is working correctly. So thank you very much once again. And as you said, I really regret that we cannot make face-to-face connection during this conference, because Palanga was always the dream place, and the conference was so lovely organized, and all the social events, they were so fantastic as I remember. And so second year in law, we don't have this opportunity, but I believe that next year they will be easier and so on. So I am talking a little bit slower, because normally I should start 10:15. So maybe someone will start watching at 10:15. So the topic of my presentation is the applied science future and the scientific alliance of academia and industry. And the case study is based on my experience, is my university BTH and Bioseco, which is the company that I cooperate with. Where is this, let's say, topic from? Why I thought that this topic could be interesting for everyone? Because most of us, we are from academia, and let's say we have some experience with cooperation, but there is still some kind of autonomy between industry and academia. And I hope that my presentation will show the light side of this cooperation, because I am very favor of this cooperation and I really love it. And I hope that I can convince skeptics who, let's say, still have some not the best experience, if I can use this euphemism, of this kind of cooperation. So you see the first slide with electronics 20th International Conference. So this is, I hope that everything is clear now. And this slide shows the pattern of our university. Here in the bottom of this is some graphics of our two campuses. So I am sitting in this campus, is a campus in Karlskrona, and this is a campus in Karlsham. And this is the photo of the campus that I am sitting. So if I can show you, my office is somewhere here. No, on second floor. No, on the third floor. So this is somewhere my office, and this is a sea. So you see that after, when I will be overwarm, I can jump in water directly. Temperature is a little bit still too low, but already I see every day some people swimming in this Baltic Sea. This is challenging. I haven't tried this year, but I plan to do it soon. So Blekinge Institute of Technology, and this is a rather small academia in Sweden. We are not the biggest. Of course, the biggest is KTH and Chalmers and Lund University. But we have very strict or very defined focus, and this is in digitalization and sustainability. So I think that this is something what, of course, is a priority in many countries and many academia and so on. So I believe that is also electronics here, because sustainability is the application of electronics. I think that electronics helping, of course, in digitalization is obviously one of the main issue to use electronics, and sustainability is also very much oriented on using electronics. So as I said, this is not the biggest university, and maybe compared with your universities, we are just a small one. So we have just less than 500 employees, and turnover is about 50 million euro. 50 professors, 100 PhD students, 11 research area, and 11 also PhD programs, because each research area is related to one PhD program. And the third of our activity is related with research. You can see also here a little bit short my CV, just to know who I am and where is my experience from. So I got my PhD from Technical University of Łódź or Lodz in 1987. So it was a quite long time ago. After my PhD, I had opportunity for 3 years internship, industrial internship in Germany, in Darmstadt. So this was quite important experience in my life, in engineering professional life. And then I moved to Sweden almost 30 years ago. And I got the docent title. It's some kind of Swedish title between PhD and professor chair. It was in 1999 in Linköping. And then in 2001, I became a professor in Kalmar. Then we moved to Karlskrona. So I sit in Karlskrona since 2007. Yes, 2007. I have PhD students in 3 research areas, in applied signal processing, in system engineering, and also in engineering, health engineering. So some 3 areas that I cover. My background is in automation and measurement. So this is what is my background from my home university in Łódź. I am teaching quite much because I love teaching, and now just almost finished with the PhD course for PhD students, which is called Philosophy and Methodology of Applied Sciences. And this year I got quite nice group of 11 PhD students from different fields, which is quite challenging because they have a different approaches, and not all of them are really pure engineering or technical students. So this was quite a nice experience, and maybe the first time I got so big group of PhD students. So this is my background in research and in education. So when we discuss about cooperation and about industrial cooperation, maybe I should explain how does the cooperation work in Sweden in industrial cooperation with PhD students. Usually the government or state try to support our cooperation. It means that there are quite a lot of projects that if I will find the industrial partner and my university also wants to invest something in this, the state can support with extra money. So this is one of the ways to cooperate. And the industrial PhD students are quite common in Sweden. It means that it is required that the company will cover 50% of the salary, which will be dedicated only for research, for PhD study. And it means, of course, that this PhD study is a little bit longer than the others, because in Sweden we have 4 years PhD study, not 3 years as Bologna process says, but in Sweden we have 4 years. And it means when this is half speed, the industrial PhD study is 8 years. So it could be, of course, shorter or longer. It depends on many, let's say, factors. And the PhD students are obligated to publish. So normal way the PhD dissertation looks as a book and is mostly a set of papers, published papers. So they are already peer-reviewed and so on. My experience that I will talk about today is for last 5 years. So this is not from a long time, because of course it would be very long history, and I will not tell you about the stone era or iron era at the university. It will be a little bit more temporary era. In fact, my first PhD student, she was also industrial PhD students, pulp factory. Pulp factory is one of the richest factory in Sweden. So this was my first experience of cooperation with industry. So the last 5 years, maybe 4 or 5 years, is concentrated on those 5 companies that you can see here on this slide. So maybe we can start with this 3D lab. And this was related to indoor localization problem. So we use indoor localization problem for spatial application for the health monitoring. So we wanted to, for instance, recognize some symptoms of dementia by the observing human movement. People don't like camera. So at home, we shouldn't use camera, but people don't like it really. But when we use this RFID technology, it was possible to map the behavior of person at home. So this was the first experience. Then we have also continue this topic with DAC. This was also indoor localization. And then they moved more in Industry 4.0. And this was about monitoring of milk suppliers. So this was some supply chain and so on. So it was quite interesting because we used different sensors or different technologies to monitor this supply chain. Then we started the cooperation with the CTM. This is the institute which works mostly with marine sea issues, and also the new things in this case was autonomous system, which I think is the main issue of the Industry 4.0. So before Industry 4.0, Industry 3.0 was more or less oriented on automation. So we automated processes, and it was main issue of application issue. But I think that in Industry 4.0 make the step forward, and now we have this autonomous system. It's a lot now discussion about autonomous cars, autonomous ships, and so on. So everything should be almost autonomous. We don't like to have truck drivers, so the trucks can be controlled or drive by the smart system. So this was quite new. And then we started with collaborative robotics. This was a fourth already company, and they got money for research related to the monitoring system, which should help to make the collaborative robots safe for people. So if person is coming too close or any situation happens, the robot should be immediately stopped. This is quite tough job because these collaborative robots became very popular nowadays everywhere, and but it creates a lot of dangerous situation. Even I will not show you statistics, but this statistics says that there are quite a lot of, let's say, even accidents with death and so on. And then the last, but not the least, company that I cooperate since several years is Bioseco. And this is also a very challenging experience because we deal with the localization, but localization of birds or animals or human in outdoor. So this is something what was quite new. And you see on this figure here that we started RFID, then we discuss also about health problems and automation or automation of diagnostics. And this is the collaborative robots and birds protection, what was the next step. Okay, so as I said, at BTH and in Sweden in general, we very much like to send the master students or bachelor student also to make their final thesis at company. And this is very beneficial for company, beneficial for university, and beneficial, of course, for the students. Why? Because the company gain quite a lot of new knowledge from those students. They are very active, very eager to do new things. And this also create my opportunity to meet people from industry, because industry appoint the supervisor from industry, and I can become the academic supervisor. So this is something what is a meeting point of academia and university. Sometimes this cooperation is, let's say, lasting for longer. Sometimes it's just one project and so on. Recently, I had some projects in Volvo, in Göteborg, and also in Stockholm, in Scania. So it's quite interesting project because they have real problems and we provide them some solution. So, but those two projects that I said already, they were not related to PhD students, but 3 projects that I got last 5 years was related to Bartosz Jachimczyk real-time locating system for indoor application. And this was DAC company, and they accepted 2 master theses in 2018, 2 master theses in 2019. So 4 master theses, which is quite big impact on the small companies. All of those companies are rather small. Some of them, they are even startups and so on. So this is quite important for them to get almost for free this research from master or bachelor students. Then in 2019, there was also one master thesis related to Intena, to this collaborative robots, and partly it was related to Damian Jack detection and classification of multi-sensor system. Damian and Bartosz, they have already defended their thesis. So they made it, Bartosz in May 2019, and Damian did it on December last year. So this is almost every year I have a new doctor who successfully defends his. Unfortunately, there are not any female PhD students in this set that I discussed. And in this year, in September, everything is almost finished. We will have another defense of David. This is sensors and algorithms in Industry 4.0, security and health preservation application. And he is working in Bioseco. And as you see here on this slide, we have had already 3 bachelor theses in 2020, and in this year's 4 bachelor theses are not finished yet, but they are on progress. One bachelor thesis usually consists of 2 or 3 PhD students. So this is a little bit bigger than just 15 ECTS. So this depends, of course, on the projects and so on. But at least 2 students join one project. We think that is also good for them, because a part of, let's say, making new things, new solutions, funding new solutions, they also learn how to cooperate. That is quite important, that this cooperation between students is working. All these theses, including PhD theses, all master theses, and all bachelor theses in Sweden are open for any readers. So you can, if you are interested in these topics, you can find on BTH database. It is bth.divaportal.org. All theses, full electronics. We don't print, we print only PhD theses. We don't print any longer bachelor or master theses. All master and bachelor theses are only in electronic form, and all of them, they are in public domain. So anyone who is interested in reading or funding some solutions can find it. So this is quite, I think, also innovative and, let's say, helping everybody. So this was about PhD thesis, about the bachelor thesis and master thesis. But now I want to show you also the academic outcome of this cooperation. So, but there are just, let's say, 5 papers, no, 4 papers and 1 UK patent application. So for the last 3 years of the cooperation with Bioseco, we have written 3 papers, and we apply for the patent, which is in progress and is quite promising. We got already first feedback, and it seems to be that we will get it, maybe with some changes, small changes. A part of this, we had a paper related to this collaborative robots, and 1 paper about the IoT-based diary supply chain and ontological approach. As you see, there is mix of, let's say, journals, but at least 2 of these papers were published at Electronica and Electrotechnica. So this was quite interesting to get this publication in Kaunas scientific journal, which really is developing and making possibility to publish more practical even papers and so on. So this is what is the results, scientific results of the cooperation between BTH, and I will skip this too. I will jump directly to, because I have to control my time, because as usually, as each professor, I love to talk and talk and talk, so maybe I will miss. So this is, I think that every professor has this, that I can talk without limits the whole day. So this is about the cooperation with Bioseco. Bioseco is a rather small company. It's about 30 persons working, but very innovative, very research oriented. And nowadays, Damian and David, they work in this company. So you see that they are interested to employ PhD students or PhD doctors even. So this is quite interesting. And they work with the sustainable development because they want to make the green energy more safe. So this is quite important. I will show you what does it mean from technical point of view. But it is quite important that what we call green energy, it could be also danger energy for some nature and so on, avifauna and so on. Apart of this, we had this protection of the rare birds, which is quite important because we extend our kingdom and we make the space for the animals less and less. So I think that is quite important that we worry about it, that we care about it. And Swedish-Polish cooperation, but very much supported by the European Union funds. What is quite important that we got this money to continue our research. So what is the market for this Bioseco product, or what are the targets of this one? So in general, there are two targets. One is wind farms. And as you see on the picture, how does it look like? We have this wind turbine and birds around. And what is the problem? The problem is that number of the birds that can be killed by these wind turbines is quite big. And it is sometimes it is not published, but you can find this data. And but this must be really clear that the green energy could be also danger for avifauna, especially for avifauna. And so what is the problem? Of course, we can stop the wind farms when there is some, let's say, migration of birds. You know, the birds, they migrate, especially from Sweden for winter, they migrate to southern part of Europe or even North Africa. And during the migration, without system which could record or monitor this migration, the farms should be locked down. And this was done often. So the system that we want to propose was related to save the life, but also to reduce of the stop of turbines, shutdown of turbines, because it costs money, of course. And so this was a win-to-win situation, not only just shut down the turbine, but also possible to shut down only when it is needed. Another target that I will not tell too much about it today is airport, and 40,000 bird strikes in 2017. And you know, the cost of each strike is $50,000 US. So the amount of money which cost each strike is a part of danger, because you know it could happen that the plane will crash because of this one. And what is quite important, that 90% of these events happens at airport area. So there is a possibility to control to monitor the animals on the runway or airports area to reduce life costs, but also to reduce the cost of possible damages. But today I will focus mostly on wind farms, because this airports, which is also ongoing project, requires a little bit different technologies and so on. So just too much would be to share with you. So I hope that you don't mind. If you will be interested, of course, you can find us or me and my colleagues to discuss about this as well. About the genesis of this solution, we see here the wind farms. This is not just singular turbine, but it is a wind farm. So it's a lot of turbines, and the birds are coming from different directions. Maybe they live somewhere close and so on. So we started with idea how to reduce the negative impact of the green energy on environment. You know that ornithologists, they are not very favor of the wind farms. And so wind farms still became controversial. Nowadays, maybe less and less of these wind turbines are placed on the land. They think more about sea shelves and so on. So, but still we have quite many on the land. And what is another problem? Different countries, different areas may have a different expectations regarding which birds and how they could be protected. So this was another challenge, that the system is not just to everybody, because different customers may have a different opinion about the way that they want to protect the birds. So the system must be enough flexible to accommodate all possible, let's say, requirements or demands from the political, for law, or for ornithology. So there are many authorities which are involved in this kind of questions. And of course, we want to help also the owners of these wind farms, because the number of the shutdown of the turbine should be reduced, that they can earn money. And so this is also the target. So there is some kind of balance between the protection of life, but also improving the economical solution of these wind farms. So you see here, what do we think it should look like? So we have some sensors placed on the wind turbine, which observe the movement around the farm. So this is the concept of a system. You see, this is how does it look like in reality. So each of these modules is placed around this turn and observe some angle field of view. And we have, let's say, 3 distances. The ornithologists, they said that it should be up to 500 meters, that we have to detect the danger situation, and it depends on the distance. We may use 3 different reactions or 3 different deterrents. So the longest, this 500 meters, is with strobe light. So this is something what make the birds scaring, and they can move from this area. When they are too close, the next step is to use audio deterrents. And this is also not very nice, because especially it is high frequency, but it is not, how to say, nice for people who maybe live close. So it should be avoided as much as possible. And then when they are in danger, the closest danger area, the turbine has to be stopped. So this is what is the last step. If we cannot make possible that the birds leave the area of danger, the turbine has to be stopped. So we have to have enough time to stop it. And it is quite possible in a few seconds just to start turbines and to protect the life. Okay, so this is another example, and you can see here the pictures. The solution is, of course, based on vision system. It means that it works on daylight, and it is very difficult to make infrared, because, you know, birds, they have a protection of the heat. So you cannot see birds with infrared. So if you would have a question, why not infrared? Because it's really difficult to see the birds, even if they have the constant temperature, but they are so small, they have very energy safe construction. So they protect any, let's say, disappearance of energy. So this is a single bird protection system module. And on next slide, I will show you some, let's say, what it consists of. So we have here 2 stereo vision cameras, which are used to observe. And why do we use stereo vision? Of course, because we want to estimate the distance of the birds from the farm. And because this is vision system, there are quite a lot of problems to detect moving object and to distinguish birds, for instance, from clouds, because cloud can imitate shape of birds or whatever. So we use the vision system, and we have here this strobo, double strobo, to make the light, and we have also double audio system to generate the audio signal, and we have even the camera, which does not belong to the stereo vision, but it controls the movement of the, so we record it for safe case and to compare results from different systems, let's say. So this is how does it look like. So high density stereo vision together with detection algorithm, and we have a strobe and audio deterrent system and turbine shutdown module. So there are, let's say, main hardware components of this one. What is required? So it is required that the system is working in real time. This was also something what is quite important, that real time is obviously required. There is no way to stop turbines in a proper time. So for this reason, we need to identify and classify the birds, because we have to estimate the time that they need to come maybe to closer to turbines. So we want to localize the birds and we want to track them. So you see here on this picture the sequence of the records of the birds which came closer. Here is the closest instant, maybe after this is leaving, and so on. So this is how the tracking system is working, that we observe, we can anticipate birds' behavior as well. So to cover 360 degrees around each turbine, we need 8 modules, because each module has the horizontal view of 45 degrees and vertical of 60 degrees. You see that what is interesting in this solution, that the cameras are oriented on sky, not on the, let's say, horizontal way, but it must be up to the sky to observe the whole sky and to eventually react for this one. So this is the way that this turbine is in the middle, and each of the modules covers 45 degrees and 60 degrees in vertical observation. I just try to control my time because I have to finish at 11. So this is, as I said, usually. Maybe we can skip some slides. So when we discuss about test, because this validation or verification of a system is very crucial. So we have to prove that the system is really working. And there are different ways. The most common is to ask ornithologists to sit and observe the sky, and they evaluate if our system react correctly or not. And what is interesting, that the system sometimes sees more than the ornithologist, than human, because human can be distracted by some behavior or something and so on. So the system is very reliable because it does not need to drink tea or coffee and does not need to go to TOA and so on. So the system is really 100% of time using. And you see the result that we have got from the independent organization in Germany of our system version 2019, and the efficiency of the spatial bird, red kite bird. So this was 96.8% of the reliability. So 30 or 31 birds, they were detected at distance 200 meters. For distance 200 meters was, of course, worse, and it was 49 of 61. And in the case of the 400 meter, it was just 54 of 88. So rate is 61. But you know the distance, longer distance, it means that we have still time to detect it. So there is always possibility to react. And false positive rate was 7%, so it's not very big, but only 2%. So it means 1/3 of the 7% would require to stop the turbine. If false positive, it means that there was no bird. It was, for instance, the cloud, and it created some reaction that the turbine was stopped. So only in 2 cases of 100, it was required to stop the turbine. So this is another test already done in Poland for the version 2020, and because we improved the software, the hardware is working quite stable, but we can use more AI-based tools. Usually this is a convolutional neural network that we apply here for bird classification. And the system, the localization is based on the movement detection and stereo vision, but the identification is based on convolutional neural network, which helps us to improve the solutions. And of course, the neural network, which is, let's say, more sophisticated due to the more examples and the history, works better as well. So this probably helps also. So I don't need to make too much now. I think that I have to go to final maybe slide. So I think that I convince you, because I am always excited by this research and by the opportunity that at university, when I am sitting here in my office, I wouldn't have this opportunity to install this system, to improve it and so on. So I think that the cooperation makes my life really exciting, because I went with my colleagues to the place and I observed it, and it was in real life. So I believe that future of research is in cooperation between industry and academia. And of course, it depends on the personal experience, but I really recommend you to find good guys, good companies which are interested in the science, in research. And I think that you will find money for this, because this is possible. More and more, let's say, funding is dedicated to this kind of cooperation. So I have some questions here in the bottom, but I don't know if we have any time for questions. So thank you.
Okay,
Dziękuję, tak, dziękuję, whatever languages you know. 谢谢, maybe some Chinese people. Okay, thank you, Darius.
Okay, thank you. Do we have any questions? Okay, so I have questions until somebody will ask you also. So, well, if there is any good answer, or maybe medicine, how to establish cooperation between higher education institutions and companies? How to establish reliable and sustainable cooperation? What is your point of view?
Yeah, you know, it is a human, let's say, machine, human to human machine. It means that it depends very much on your relationship with this person. If you have a good relationship, personal chemistry must work, you know, so you have to trust to each other and so on. So as you see, my Damian, David, and Bartosz, they are very happy to cooperate with me, and the companies as well. So I think that it depends very much on person to person. So you have to find the person whom do you like, and he or she likes you, and cooperation will work very well. I guess it's the easiest way.
But I suppose both sides should have intention to make, yes, to make.
Yeah, you have to be open-minded, of course,
interest.
you know. I think that sometimes it's even more difficult from companies' side, because they think that we are academics and we are only in clouds and so on. So they're afraid that we want to publish only and so on. But now with the funding from European Union and from some research, they require also the publication. So what makes the company happy, because when we started, and now I show that we have so much publications, at company, they say, yes, it is so easy to report the, let's say, outcome of the project, and nobody has any doubt about it. But they have to believe that research is useful for them. This is not easy. No.
Yes, and what about outcome? Do companies expect research or final result, let's say like a system or something similar to system that maybe a light prototype or something else? What is your...
Of course, they need money, so they need the product. But if they got support to develop the product from a research council, and they require the publication, so it seems to be, but they see, I think that I convince my colleagues now that when we make research on deeper way, they understand their system better and they can improve the system, because this is always, when you just do the product, you are on the surface. But when you dig with details, with models and so on, they find, oh yes, this is something what we can, the analysis is not the best, let's say, at industry. Usually they make the product, but they don't understand the product so well. And even big industries, like Boeing and others, the accidents happen. Instead to dig it in problems, they just make the product, already sell it, and apparently there are big accident and so on. So this is something what has to be clear, that research really helps them to understand their system and to improve the system.
Okay, thank you. So do we have any questions from auditorium?
Dear, may I have a question, please?
Okay, please.
It's from Turkey, Fikret, Fikret. We have an institution called TÜBİTAK, Turkish Technological Institution and Research. This institution supports common research between the universities or companies from different countries, especially from European Union countries. Turkey is contributing to this common budget, so the institution is really keen to support such research. My question to Professor Wlodek is, will it be possible to propose a common research, to make a common research proposal to TÜBİTAK, the Turkish?
Absolutely. I am always hungry of new challenges and new proposals. So
thank you.
Darius knows that we always searching for some new cooperations and so on. Everything what is related to sensors, AI, algorithms, and so on is in my field of interest and so on. So absolutely, I am interested in any research.
I contacted TÜBİTAK and I asked them whether they will be keen to support a non-invasive glucose measurement, biosensor or nano biosensors, and they keen to do such research. As one of your research area is health engineering, I think it might be interesting to you.
Any non-invasive measurement is in my field of interest, so this is absolutely. Okay. So just send me email, you can find my email in this fields and so on.
Thank you very much.
So good luck.
Thank you, Darius. Thank you.
Okay.
One short question, if possible.
Okay, please.
Okay.
What is your opinion about the patents? Because industry is not very keen to share the intellectual property, yes, but researchers want to publish all the results.
I started to negotiate with the management of the company that we need the patents, but it is very costly. It is also demanding to prepare good patent, and company usually should have this patent. I don't know at different universities, maybe there are different approaches, but in my university will not be owner of my patent. I am owner of my patent. So when I cooperate with industry, the industry is owner of the patent. So university does not in any way wants to share this patent with them, because in Sweden, the university, we may not be owner of any property and so on. So, but if I will apply for patent in Sweden on my own, I can get the money from some foundations that they help me. So I think that it is important to have the patent for companies, because if they don't do it in time and they have really something what is tricky in technology, they need to protect their solution. If they don't do it in time, they can lose. So this is also the time that when we wrote the paper, sometimes we had to postpone the publication, because until you apply, you may not publish. But this is my experience already from Ericsson and Volvo, because they also had the same case. I wouldn't allowed even to publish the thesis, master or bachelor thesis, before they will apply for patent. So they postponed this publication, and this is possible at university, or even, you know, when we have the with some military applications, the patent of the report is totally hidden. So this is possible. But the patent, I am just obviously favor of making patent. And I think that academia, when I put in my CV that I made the patent, they don't count it maybe in some countries as some kind of extra points, but at least it is appreciated in my university. I don't know if I answer your question. Thank you.
Okay, thank you.
Thank you.
Thank you. So are there any questions? Okay, so if not, so I would like to thank you to Wlodek for the presentation, for the invited speech. And now we have a short break, maybe not a short, but it is around 37 minutes, and we will back 15 minutes to 12.
Okay.
Okay.
Thank you. Thank you very much for opportunity. It was my pleasure. Thank you.
Thank you, Wlodek.